हाय कुलदीप। हेलो। 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 हेलो।
हेलो सर।
हाँ, हाय कुलदीप, हाउ आर यू?
ये है सर, आप बताओ।
आप बड़े हो, तुम बताओ।
सर आपके पास कोई
कुछ
बॉक्स कन्वर्ट का कोई उसका कोई
हाँ।
फाइल पड़ी है क्या आपके पास?
किसकी?
बॉक्स कन्वर्ट की।
बॉक्स कन्वर्ट की दे दूंगा, मेरे पास होगी, लेकिन हम तो वो करते हैं, डिजाइन करते हैं ऐसे नॉर्मल बीम, लेकिन तो एनालिसिस तो अब डिपेंड करता है, तुम बॉक्स कन्वर्ट को इसमें करो।
ये एक्चुअली क्या है कि मेरे पास एक काम आया तो मेरा बॉक्स कन्वर्ट डिजाइन करना था, मुझे सब कुछ चलेगा।
तो
तो
एक्सेल
रेफरेंस
में
में
देख लूंगा अगर पूरी एक्सेल हो, वरना तो सिंपल तो ये होता है कि मेरे पास डिजाइन एक्सेल तो है, मतलब जिससे डिजाइन हो जाता है, लेकिन एनालिसिस जो होता है वो हम अपने मिडास में ही कर लेते हैं या स्टैट में कर लेते हैं। वो फोर्ड से निकालनी पड़ेगी, बस ये रहता है।
अच्छा अच्छा।
क्योंकि अब हम ऐसा होता है बॉक्स कन्वर्ट में, मैं बताता हूँ, बॉक्स कन्वर्ट अभी हमने वैसे डिस्कस नहीं करी है, थोड़ा बता दूं। बॉक्स कन्वर्ट में ना सॉइल की प्रॉपर्टीज आती हैं।
हम्म।
ठीक है, तो
ये
वो
आप
सॉइल
एक्सेल
की
अगर एक्सेल शेयर कर सकते हो आप एक्सेल शेयर कर देंगे, मैं तो देखता हूँ उसको।
किसका
है ना?
क्या कह रहे हो, दोबारा बताना, समझ नहीं आया।
अगर एक्सेल शेयर कर सको तो एक्सेल शेयर कर देना सर।
अच्छा, शेयर एक्स्ट्रा।
एक्सेल शीट है ना किरण, बॉक्स कलर की एक्सेल शीट है आपके पास?
हाँ हाँ, मैं दे दूंगा, लेकिन उसमें एनालिसिस नहीं होगा, सिर्फ डिजाइन डिजाइन होता है, एनालिसिस तो
नहीं,
तुम्हें
एनालिसिस तो एनालिस्ट नहीं
इस
है तो भी
हाँ, मैं
आजकल।
वही बता रहा हूँ, एनालिसिस या तो तुम्हें मिडास में करना पड़ेगा या स्टैड में।
हम्म।
क्योंकि एनालिसिस से ही फोर्सेस आएंगी ना, फोर्सेस डालो डिजाइन हो जाए। बता दो, मैं
हम्म।
दे दूंगा। क्योंकि मुझे एक
मेरे
बार
पास
याद
क्या
दिला
है कि
देना
एक,
व्हाट्सएप पे।
एक क्या है कि हमारे क्लाइंट उन्होंने बोला है क्या तो स्ट्रक्चर
हाँ
के
नहीं,
लिए
कोई नहीं,
कोई
मुझे व्हाट्सएप पे एक बार कल मैसेज कर देना, तो मैं सेंड
तो
करूँ।
वैसे उनके उनके उन्होंने मुझे पीडीएफ फाइल दिए थे कल को, इसमें सुनना आ गई मेरे को। वो क्या है कि उनका
अच्छा
जो
अच्छा।
बंदा है उसने क्या उसने स्टैड पे डिजाइन कर रखी है।
हाँ, स्टैट डिजाइन नहीं होती, एनालिसिस होती है। एनालिसिस मतलब उसकी फोर्सेस आएंगी निकल के, बस स्टैट से
सर सर
निकाल
ये
दो
एक
फोर्सेस।
एक ये पूछा सर, स्टैड के अंदर आईआरसी कोड तो है नहीं?
नहीं नहीं नहीं, तो तुम्हें मैं बताता रहा हूँ, वो डिजाइन नहीं करता, वो सिर्फ फोर्सेस देगा, लेकिन मिडास डिजाइन भी कर देता है।
हम्म।
हाँ, स्टैट डिजाइन नहीं करता, स्टैट सिर्फ आपको फोर्सेस देगा और कुछ नहीं। आप फिर उस फोर्सेस को अपनी एक्सेल में डालोगे, फिर उससे डिजाइन करोगे।
नहीं, एक्चुअली क्या है इसमें कि जो मेरे पास मॉडल आया था ना उसमें जो केसेस बने हुए थे ना, लोड कॉम्बिनेशन बने हुए थे,
हाँ हाँ।
वो देख के लगा था कि ऑटो क्रिएटेड है। तो
हाँ, ऑटो
उसमें क्या है,
क्रिएटेड भी
तीन
होते हैं।
तीन केस बने हुए थे। एक तो बेसिक था, एक रेयर था और एक वैसी था, जैसे आप बताए
हाँ
थे ना वैसे।
हाँ, ऐसे ही होते हैं तीन केसेस, देखो। बेसिक स्ट्रेस के तीन केसेस होते हैं, और स्ट्रेंथ और स्ट्रेस स्ट्रेस नहीं, सर्विसिबिलिटी के तीन होते हैं, और अल्टीमेट के एक होता है। मतलब अल्टीमेट में फिर सीस्मिक भी आ जाता है, कोलिजन भी आ जाता है, या फिर और बाकी जो नॉर्मल होते ही हैं। तो उस अल्टीमेट में
हम्म
हम सिर्फ चेक करते हैं कैपेसिटी, शियर और टॉर्जन, तो वी चेक ओनली
हम्म
दिस। लेकिन इसकी बात करते हैं सर्विसिबिलिटी की, तो उसमें बनते हैं रेयर के और तुम्हारा इसके क्वासी परमानेंट के और फ्रिक्वेंट के। तो फ्रिक्वेंट की तो
हम्म
जरूरत नहीं पड़ती, उसमें डिफ्लेक्शन होता है, अगर चाहो तो चेक कर सकते हो, वैसे फेल नहीं करती है डिफ्लेक्शन में। डिफ्लेक्शन होता है, फिर स्ट्रेस होता है, स्ट्रेस चेक करनी होती है, और क्रैक फिट होती है, क्वासी परमानेंट बॉर्डर होता है। क्रैक फिट गवर्न करती है हमेशा किसी भी स्लैब डिजाइन या कलवर डिजाइन में।
हम्म।
तो दैट नीड्स टू बी चेक। हाँ, वो वैसे ही सेम IRC 11 IRC 6 we need to follow, and do not any issues with that. Even generally people try to copy paste the mm, load combination from one model to another model, no issues with it. You can also do that. I will try to do this to find out and send you. Okay, so we were discussing yesterday about the MEDAS. We have completed up to the normal loading and our construction stages. So now we need to create the load combination. So first we will see how it is create automatic, because automatic are also there, and you can create according to your no issues with it. The automatic is like same thing, but you will get lot of combination. Previously, I think I have shown you also. So if you go into the load combination, and we do not need to run again. So here it said auto generation. If you click in auto generation, this kind of window will open. Now here it will ask you which kind of option you want, add or replace, add envelope or not. Then it will ask you code selection, steel, concrete, SRC or steel composite. So we are using steel and steel composite. So we will use steel composite. Now here it will ask you this like Ashto. Here, if you look at here, it will not show IRC code. But if you look at the steel one, then it will show IRC 6, because even if we are designing as per IRC 22 or 24, IRC 6 gave us all the code, this combination. So here we can select IRC. Now here it will ask you construction stage load will be considered or not, or structure only, construction stage only, or both. So we generally consider both, but here what is the issue? We do not have any CS construction stage loads like pre-stress and all, but we will still consider it. Sometime it will not consider or anything. And we have also moving load for a special vehicle. This is the special vehicle. Road traffic, not showing anything. Traffic load, I already considered it. Road traffic will be your, if any other loads you want to consider. Now, if you click OK, it will quickly generate you everything. Now, if you look at the one, so it is now here also have been mentioned, and here it has been mentioned like this is a description they are giving. 1.5, 1.35. This is characteristics. Like stress frequent, quasi-permanent, and above that are all our strength one. This TR1 addition. So here and now, when you look, if you want to do the steel design and composite design, so here nothing have been shown. So what we need to do, we need to select all the load combination, and we need to copy into like steel design and also in composite design. Now, if you go into steel design, it will show all the load combination which we have created. And if you go into the composite design, it will also show all the load combination. So that's how we need to consider those things. And if you look every combination, you can able to see like first it is taking class 2A vehicle, then 70R fatigue, and special class 70R. So temperature changing to class A. Special vehicle again. So we can easily able to see, and what happen in this, it divides, it consider combination as per our this thing. If you go into the load, and we have done in a static load, there is this static load case. So it consider combination by these things, the type of load we have provided. We have provided wind, we have provided temperature, temperature gradient, or any earthquake or braking. So it automatically distribute. So Midas already knows. This is smart. So Midas knows according to the type which required. So now another thing is that we know that we do not need to design bracing in steel composite, and we do not need to design steel composite with the steel girder. So both things are different. First of all, you need to understand that everything will behave differently. So that's why how we consider it for the design part. Design is pretty much, if you go into the design, there we are not going in PCSE. Previously, I have shown this kind of thing, PCSE. So here we do not go because this is totally applicable for PCSE gutter, not for any other. So if you go into design, there are first of all steel design is here, then RC design, SRC, composite design, and here is the common parameters. Because first we need to do the steel design. If you click on the steel design, and we need to select our code. Now, if you look at the code, generally all codes are available. ASHTO 17 up to AISC, then Euro code BS5950, IS 800, LFD, like LSD, limit state design, and IS 800 1984, ASD, allowable stress design. Then IRC 24 2010, this is again LSD. Then this is CSF or this Canadian code. So we need to select IRC, and then we need to select the common parameter. First of all, definition of frame. So we are looking our steel frame. Frame is because we provide the bracing. So brace, non-sway. In Y direction also we have brace. So in both direction we have brace. And design type, now it will ask the design type will be in any plane if you want to do. Then it will be considered the CD, and we can also select effective length parameter also accordingly. And we will select OK. Now load combination do not require member assignment, reverse member. There is another thing. One thing I need to modify member type. Yes, this will be here. Now here, if you look at here, we need to define which is bracing, which is beam, which is column. So here, this is our bracing, the X1. This, and even the bottom X. So let me first select select this. That's how we can able to differentiate. Bottom one is already. Now you will select the bottom one also. But bottom one, you do not need to select this one. So let us just what I'm trying to say, we do not need to select this. This will come into beam. Just deselect. And now what is okay. This select. I need to be carefully then selected. Or if I do like this, what I can do, I can select like this. And click on this thing. So this will going to be deselected. So these are all bracing. Click like this, not all the things required, and click apply. Now it will consider this thing as a brace, and we will select our end diaphragm, our this bracing top one, not this one. Now we need to select also the bottom one, but for bottom one little bit need to do it. That means for this one, this one will come, this one will come, this one. This and this will come into your beam. Click apply. So this will become beam. So there are two important things. This reverse member, local direction do not require, unbrace length. Right now, in this not required, limiting slender ratio do not movement. These are all not required. Now, if you have this common parameter, define it. So first of all, design code we have already considered. Now steel material. So if you look at here, it will ask me which material you are going to provide. So we have already considered for E350, for which our yield strength will be 350. But generally, if you have seen for bracing, generally this is sometime maybe low strength steel also you. So you can update to 250 also for bracing. But right now I'm checking for this. So this is fine. Or if you want to modify it, bending option do not require, steel design table, not. Now you can click on steel design code. So it will run one command.
So these beams are our girders, sir.
No. Beams are your bracing which is connected transversely. If you
Now
remember
we
it.
have not selected any girder members.
No.
for assigning it.
Girder will be designed as a composite. Yes. We have not.
Now we are only considering the steel
First
part.
of all, yes. First of all, steel part we need to deal with.
Okay. Now we are designing the beams connected and the bracings.
Yes, only end diaphragm and bracing.
Those
Because
are
those
also
will be-
E350 grade, sir.
I have considered same grade for all. It depends. That's what I'm telling. You can consider right now higher grade. But if someone asks you, maybe I require this in the lower grade. Now, if you look at here, it will try to give you this thing. It is checking right now as per properties. If I click as per member, we will have lot of things. But right now I'm checking as per properties. Now you can see the ratio also it is giving. 0.4, 0.35, 0.35, 0.6, all are okay. And if I click on this, there is one more thing.
What, sir? What ratio, sir, it is giving?
We need to, I will show you. Wait a moment.
In
First of
steel,
all-
what are all the parameters we need to check in the design first? So that one you just tell, sir.
Let me wait.
Hmm.
I will again show.
Concrete, we know all the things. Stress check, crack width, whatever we
In
want to
steel,
check.
it's different. In steel, the main ratio is your the capacity as per the demand. You do not have a stress check and another. In steel, there is only axial force plus the bending moment check. Nothing else.
Okay, shear,
Or
shear,
cement.
sir.
Shear is for the web, but generally shear does not that much govern for the bracing one. Axial force govern.
Okay,
Wait.
once tell that, sir. Steel
yes.
design, what are all the things we need?
If you look at here, this N is my axial force. My is my movement in y direction, like major axis. Mz is the movement in my minor axis. Vy is your shear force in the minor axis, then Vz again the shear force in my this major axis. So if you look at here, this forces they have given, and what I want to show you detail. I need to select a member like this one. There is one more thing. Table, what I am looking at it. It shows graphic detail also, like this. So this I have selected right now and diaphragm. So it is showing first of all KL upon R ratio. KL upon R ratio is your slenderness ratio. So first it is comparing that KLR should be less than 180. So that is less than 180, 90 is coming. And another thing, another check for axial strength, then bending both direction, then combined check. So if you look at the combined check is the most important, which is the showing ratio of 0.446. Then afterward, it is checking the shear force. Shear force will be very minimal. Your governing in steel always the same. In bracing and all will be your axial force and bending. So if you look at here, this is just the normal check. It does not have any detail criteria. Now if I click
Sir, slenderness, always it should be less than 180. That
Less than
difference is there,
180.
no, sir? Short, long columns or short,
No,
long,
that
something.
that is different. That is different. Column is different. Column, short column, long column is your 12. It should be less than 12. Slender is different. Slender is your web thickness and the flange thicknesses. If you are because our code does not allow to design the slender section. That is the issue. And if you go into the higher code like ASHTO and Europe, this code allows us. But Indian code limits us. We do not go in the slender, because what will happen due to slenderness, you will get extra additional secondary moments, and so we do not going to do. But column order out, and that check is only
No,
for
what are all the
12.
types, sir? Slender, then after that, sir, non-slender.
Not the
That's it, or
cylinder.
what?
You have compact, semi-compact, plastic. First of all,
Okay.
plastic, compact, semi-compact, compact, semi-compact. Cylinder is also there, but only for the column is there, which will be KLR upon ratio should be more than 12, and it can be limit up to 180. Still, we cannot go up to 180. If my
What, sir?
KLR upon ratio is less than 12, so it is known as short column. Okay. Then if it go beyond 12 to 180 ranges, it is known as long column. But it cannot go beyond 180.
So 180 is the maximum limit.
180 is the maximum limit. So for beam, generally, we do not have short and long beam. So 180 is the limit, but only column has this kind of limit, short and long.
No, that is okay, sir. Here, there is no bifurcation about plastic, compact, semi-compact, all those things. How that will be defined, how, sir?
Let me check it, because definitely you do not require until for a section it will be detailed. Let me see. Now these are the forces that have been considered. Thus classification only required for your beta factor, yes. But let me see, it is considering those things or not. This is just normal thing. By forces, it is mentioning that how much it is coming. Where is you can see here classification of my section. So it is classified at semi-compact. You can see that table simple has been given in the code. I think I have shown you that thing. Let me open that code also. It's very simple. Nothing have been. So code is all this also checking it. You want to see this na classification 250 upon EY. That's how we check it.
Now go from up, sir. This is the detailed design, whatever Midas is
Yes,
given.
detail, but yes.
From
Then
top,
axial
one by
strength.
one, just if you go, sir.
Top is loading have been more loading, nothing else. The load, all these load combination, it will give you. Maybe wait a moment. I can do not right now. I will show you one more. There is one detail. You can get detail according to this. Then there is a summary also. In summary, we will also get the same thing. All the load combination have been mentioned, and only this kind of thing is mentioned. In summary type of, like if you want to attach the summary, generally someone, if you see the design report, always people ask where is the summary. So summary we put at the end page or the front page. So you can directly copy. And if you want to see everything like detail, then we have detail, then graphical. There is one more thing I want to, connected model. Why it is, now if you look at here, if I press this button, you can see which member I am checking. So this is end diaphragm. Both end diaphragm. Now if I press this button, it will showing this bracing I am checking. And if I click this button, it will show bottom bracing we are checking. And we can click on this detail. For detail, first of all, it will give us the load combination, a little backup that these numbers of load combination have been considered. Then it will show you what are the material properties. First of all, design parameter. Now it will start the first of all section properties. Okay, built up section or even the we are considering all the build up, and this is ISA 100 into 100 into 10. Then it's a depth, width, everything it will mention. Then area, then ASY, AZ, Y bar, like neutral axis Y Z. Then section modulus, then RY, RZ, these will be required for your radius of gyration for calculation of compact or not compact, or the your this slenderness ratio. And then material properties, first of all design parameter, then material properties, then it is showing moments. Okay, that forces, axial force, shear force, bending moment, everything. Then partial Shakespeare factor. Again, these are the common one. Then code which are mentioned, and then equivalent uniform, nothing required. Classify section, then it is classifying semi-compact class 3, then checking axial strength, then checking shear strength, then checking I think combine in local Z direction. Okay, yeah. Bending check, strength about major axis, this is bending. Strength about minor axis, then combine check. So this is the combine check, will give you the ratio 0.6. You can see here, this is the main thing in steel. We check it. We do not do a lot of like concrete other checks. This is the major check in steel. We always do. Steel always depend on to your combine check. In combine check, remember axial force, bending in Y direction, bending in X direction consider. Not shear force. Shear force totally check will be different, and it will generally depend on the webs, but for the angle it will depend which axis will there. So accordingly, now if this is the most critical section, it is showing. Same for this one. If I click this and this, it will show me the detailed calculation. This is the graphical one. Like anyone want a little bit, where is it was shown now? I've shown you where it has.
So it has designed all the members which we selected, sir.
Yes. It design all the member. Even if you want to see all the member, how I can see. Here is one more thing. I am selecting property. If I change into member, you can see all the member. Now here all have been selected. But now if you want to see any particular member, if you click here, this member have been shown. Now you can go below, you can click this member have been shown. Everything you can get anything, whatever you want, which member you want.
Now, which is critical if you want to see means?
By going the property.
Okay.
This is a critical one it is showing. You can click here, you can see the detail, graphic. Graphic was not able to come in. This is the one, I do not know why it has been hiding. And this is the table, designed the table, if you want to pay. And we can copy this summary, detail, graphic. And this is also showing the ratio here. One more thing is that if I, let me close that. And if I go into the design. In design, there is one more thing. There is steel optimal design. If I click this thing, it will try to automatically optimize it. Maybe I will try to do. So now you can see here, it's saying about end diaphragm. That in end diaphragm, we can able to do something. I do not know what was previously there. Maybe I need to see it. So 1.75 built up now, and it's changing end diaphragm, but 12 mm to What? Let me click this. Design and analyze.
Sir, this optimization for all members we can do, or it will show which one we can optimize
No,
like
no,
that?
only some, like it will automatically give us. So it is saying it is still doing it. Not only steel members, not for the composite one.
No, no, steel members only. Whichever is
Yes.
whichever can be optimized, that only it will show,
Yes,
or it
yes.
will show for all.
No, no, no. Which can be optimized, not for all. This is Midas have already inbuilt some. I do not know the accurate one. Some algorithms are there that this member can be optimized, so it will automatically tell us that you can optimize this one. Now, if you look at here, it is checking and doing something internally. But this is generally we do not do that, but I'm showing this option. Generally, what we do, because we know if we are doing changing something, we do according to our own drawings and application. Now it is reanalyzing, and then how much it will analyze.
Sir, in our
That's why
design option, recalculation was there, no, sir?
Yes.
Means if it is failing, then what we have to do?
If it's failing, then again you can click the optimize. So, or you can increase the size also, increase the depth, increase the plate thickness, increase your web thicknesses. It depends where it is failing. You need to see the detailed result. If it's failing in the bending, you can increase the thickness of web. If it's a failing in your area, no web nahi flanges. And if it's failing in the axial force, we can increase the web or flanges both. And if it's failing in the shear force, we can increase the web. So it totally depends.
In capacity check also, not general. In deep in where it is failing, like capacity check, MX is more or not. Which one is more? Where it is failing like that? Sir.
I've shown you, na.
That is what individually.
Individually have shown you, na. Let me again. Then I need to again. No, there is.
No, that is okay. For example, if it is greater than 1.
Yes. So we need to see now where it is failing. We can check in the details. That is what I told you, in stream that I need to again run. Because your gutter will generally, our steel member fail in combined check, not individual check. So first we need to see in which individual is coming more. Like my moment is giving 0.6, my axial in major axis it is giving 0.6, axial is giving 0.3, and in minor axis it is giving 0.3. So it will become 1.1. So major axis is the main one which is failing. So if I change my major axis, like my flange thickness I will change. So it will also going to affect other axis. It is not like that only major axis. Now if you look at here, okay, I think it has done something optimization. We need to see what done. So if you click on this and you can click on the detail, so you can clearly able to see, first of all, your section always going to be fail in this combined check, combined forces. So right now it is 4.68. Now if it's more than this, you're getting my point. So we need to see then individual check, like flexure strength is 0.6 and check question. Minor axis is 0.001 if you look at here. And my axial strength check for shear. Shear does not required in combined check. There will be axial at the top. Yes, it is 0.062. Like if you have seen combined check also bidirectional moment check in columns also. Have you seen as per SP16
Yes,
or
yes, sir.
this? So that is the thing here. Same nothing. So it is showing like this. So that will be fine. So this is a combined ratio.
So in this
And
member,
right now
which
we
is
have checked
major
out.
and minor axis, sir? Major and minor axis.
Major and minor axis we can see in the graphic one. You can see this one.
Can you zoom,
Along
sir?
the Y, you will be the major one, and along the Z, you will be minor one. I think I cannot able to do this thing. Let me create. There is no zoom option. Can you able to see now or not? Here you can see this thing.
Yes,
My
yes, sir.
mouse. So
Huh.
this is the section. So this is Y1 is the major one, and Z1 is your minor one.
Means our thickness web, that's our section where it is, sir.
Along the web, it always generally comes, not always, but if you rotate the section, then major minor will change. So you need to see how you have made your model or how you have provided it. So this is the major one is Y right now. If your governing moment in MZ like MY, so that will be our major one. Because we need to check in MY. If you remember it, MY moment will be there. So in local axis also gives the Y will be major and minor will be perpendicular to the major one. That is this Z1. And this is the normal small table is also there. If someone asks you to give you a small thing, you can give this just this result. That is also okay. If someone is not asking
This is
that.
which option, sir?
Here three options are the graphical, detail, and summary. Summary will give you only summary thing like this.
No, you open
And,
now. That is which one, sir?
The graphical. This one.
Okay.
Then you have detail, summary. All things are here. So let me close this. This is for steel design. If you want to design any kind of steel, if you want to design building, if you want to design any industrial member, you can design anything with Midas very finely, no issues.
Sir, this recalculation option, when will you use, sir? Here.
Where is the recalculation? Here nothing have been mentioned recalculation. With this, okay, if you change any member size or anything, so it will recalculate it. Or if you want to do something other thing, just for this thing, nothing else is there. If I click it, no selected members. So for selected member, it will try to recalculate it. You can see rechecking the member.
If we
Nothing
change
else.
anything in the model, then we can
Yes.
recalculate it.
Now, if you see this graphical, why generally it is there, but I don't know why it is hiding or doing something. If you look now, this is my angle section. If you remember, that's how we have model like this. So when this is y-axis, is my major axis along this y, and z1 is minor one. So that because that's how we model it. So that's how it is going to be considered. If we change the modeling direction, then here direction will be changed. It totally depend our modeling perspective, how we are modeling. Because a software will consider the local axis of modeling, not it will not ask you to input your axis or anything. Whatever you have modeled, it will assume that you have modeled correctly, and it is going to be casted the same. So that is the one thing, remember it, if you are doing the design, your modeling should be very accurate. If you have axis changes in the modeling, then your result will be different. Because minor axis become major axis and and the major axis will become minor axis. For that thing, everything will fail. So that is become critical. That's why. So now we will.
We
talk
have
about
rotated
the-
one angle section to 90 degree and
Yes.
all, no, sir.
These are the rotated one, na? So this is the correct way. Because actually at the site also with the gutter, this is how they are going to be, you can say, casted or going to be constructed. This is the correct axis order. That's why I have changed it, if you remember it. At the time of applying it, it is giving different direction. So that now that thing comes to effective at the time of design. That's why I'm mentioning whatever I'm doing, everything will going to affect our design. Still, man, modeling should be very accurate. If you done any error in the modeling of axis, your local axis, steel will fail. At the construction in the design, steel have always workable for both the axes. You will have both the movement, and one will be major and one will be the minor. Until unless if you are using box section, like square hollow sections that have both equal axes.
If you are designing in the Excel sheet and taking the result here means, sir,
What you got? I do not able to understand this. Can you repeat?
no, only the results we are taking and design if we are doing in the some
If you
in some other
then
way.
you have to. If you want to design in anywhere, you can design it same method. Nothing will going to change. You need to take out the forces, but you need to be confirm about what is my major axis moment and minor axis moment. So that need to be confirmed, and then you can design it according to the axis, because your capacity totally depend on your axis. You will have section modulus of your major axis higher and section modulus of minor axis will be lower. So that totally depend on to your axis. You getting my point now?
Yes, yes, sir. Sir, the table you are trying to show
Table.
capacity, not classification of section.
In code. IRC 24. (24) 2000. This is section B. Section classification, nothing but just initial consideration. Generally, do not that much effect. If you have compact, semi-compact, or only
Which should not be there, sir. Nothing like that, sir.
What?
Which is what to say? Which is good, which is not good, which should be which should come, which should not.
Which is the best is plastic one. Then afterward compact, but plastic one will give you a more conservative result. Then compact will give you again conservative. Semi-compact will give you economical result. Here a cylinder option is not here as per IRC 24. But if you check the IS 800, it is directly copy from IS 800. Nothing have been changed. And that is the main benefit in steel design. If anyone has worked in IS 800, it can work with the steel. Like
okay, same, sir.
Yes. Let me show you. This 1 to 8.
Formulas, everything is same.
Everything is same. Everything. Only change will happen because of composite one. Because IS 800 does not define any composite thing.
That is 22 code.
If you,
IRC 22.
Now, if you look at here, IRC 22, yes. Now, if you look at here, this is as per IRC 800. Even also, yes, IS 800 does not provide for cylinder one. So, I do know, maybe they will going to include in the latest one. So, you can say 9.4E, 10.5E, 15.7, 9.4E, 10.5, 15.7. Everything directly copied from IS 800 to IS 24. Now, IRC 24. So that is good for a steel design. Everything is directly copied. Even this moment capacity, if you look at here, and just everything is copied like this. So I will close that. Only some extra things will come, but other things are. Let us close this. So we will discuss about now composite one. So for composite one, again, we are in the results design tab. So we have explored this thing. Now for composite, it is mentioned like here. Here, first of all, we need to select our code. So if you look at here, different codes are still available. Like Ashto, Europe, CSA, SNAP, SP35 is also there. IRC 22, 2008 and IRC 22, 2015. So we use IRC 22, 2015. Now here we need to first of all, if you want to see the design parameter, these are directly come from the code itself, like stress limitation and these 1.5 for the seam concrete basic and seam combination accidental 1.25 these all, and these are what checks you want, like post buckling tension field action. Up now this option is for if you read if anyone has read uh, design of steel structure in college, if anyone remember it, there are two methods available. One method is known as simple post critical method and another method is known as tension field method. So these two methods, what they said about it, if we consider simple post critical method, we can design it without stiffener. We do not require any stiffener. And if you want to provide for the connection, that is up to you, but we can design it without any stiffener. But if you want to design for tension field method, we need to consider some stiffener spacing. Stiffener will be there. So here, what is the post buckling tension field action should be considered or not? So this is by selecting this, it means some stiffener will be there. Actually, our girder has a stiffener for connection. If you are even providing for connection, that means it will behave as a stiffener also. Because if you remember it in this drawing, this thing will behave as a stiffener. This thing. But this is also behave as my connect with gusset plate. Every connection will be connected to it. So that's why we can consider it. And now it will ask you the checks. Bending resistant, then resistant to vertical shear, lateral torsion buckling, transverse force, longitudinal shear, fatigue, then serviceability, stress limitation, longitudinal shear again, deflection and crack. Crack for only your concrete one. And yes, these are fine. Let us close that. Then again, design material. So we can click here. Now, if you look at here, we have been using, yes, this is fine. But for one more thing I would need to show, we need to provide reinforcement. IRC should be here. Grade will be 40. Concrete grade, reinforcement again. $500 modified. Design elder will go, but one more thing I have forgot about it. I need to go on to the one more, 1, 2, 3 important things are there. Properties, section manager, reinforcement. Here. Now, if you remember, we provide this reinforcement for other girder also by input method this. First of all, create grid line. 0.03. Then again, starting point, I will use CTC number 200 mm H bar. Okay, it is showing me this as per ACI, this 4 will behave as a 12. And now it will ask me part 1, part 2, so it will be in part 2.
Not IRC, sir. This is
IRC, but units have been considered like matrix units. So these two it's fine. Do not require any shear enforcement, just apply it. because we do not checking any web. Steel web is there. Then again for this one,
So we need to draw something, sir. That will be yeah,
Right.
drawing it. Na? Yeah.
it is already come by. Now I want to apply for this thing. Just providing for all the gutters. Now one more important thing will be here, effective length. So we need to go in a structure. There will be steel composite. Now we will give span information. So in here, span information like girder name. First of all, we will check. Okay, we will give for
Where it was, sir? This one, this tab.
in a structure. You will have PCSC for span information section enforcement also. Then in composite brick, you will have span information and effective widths. So first of all, we need to give span information because according to the span, it will calculate my effective width. Now here is one more thing is it will ask you this, what is my mid girder or what is my extreme Y girder? Like, we will have two kind of girders will be there. One, two, generally everyone know, mid girders and end girders. So here I will differentiate, like I'll mention G1. So G1 will be, I need to select those elements. Maybe I will select this one. Click on this. So my girder is this from to this. And this is this starting point. The number of span have been entered is not consistent with the number of span specialized element exact span. Where I have mentioned span anything, I have not mentioned anything. I have mentioned girder name, add and replace. Yes, you can able to see like this. Now we need to provide what is I point and what is J point. So we will see what is I and J. So 230 is my I point and 303 is my J point. So I click add for this one. I will also create for one more for middle one. This and click OK. Now this also by like G2 I will mention it. And for this again I will select. But here one thing I will select, this is both. Both direction girder is available. First of all add. Let me see, it is coming to I point.
This is what, sir? Local Y, that axis, how to select, sir?
Which, yes. Let me look at it. This local Y is like the starting and end points. So generally Y started from this point. Y will going like, this is the axis. So Y in going is this direction. So this is my starting point. So starting will come with positive Y. And whatever the end girder will be there is the negative Y. And in between whatever kind of girder will be there, it will also always consider as the both. So let me close this. And now we will go into here effective width. Now if you look at here, it will ask you like this thing. It is saving. So scale factor will be 1. B not shear connection, shear connector distance it is asking. So we can consider at 0.15. And code will be as per IRC 22. You can click OK. But they have taken tax editor. I don't know. There is one more thing there. Here
Effective width means what it is calculating, sir?
width will be required now. I've shown you this thing. My effective width will be BM1 plus BM2, not the full width generally. But it depends. Sometimes it comes directly the full width. So it depends totally on the span information and the available width. I want to see the result.
This value where we have entered, sir.
Nothing you need to enter. Just here. Consider the variation of center. Fine. Why it is opening this syntax editor? Taking wherever it have been added. Let me see. I'm always taking me this. Do not require G and it is taking me somewhere else. Wait a moment. If I select this one, activate. I go into this. Again, it is taking like this. Why it is taking? Okay. We will deal this. You can see here, B effective, B1 is there, B2 is there. So that is the thing, but why it is not being considered? Like if I select to member, always taking in there. Okay, close that. I will let you know this thing. The span information we have already given. Now we need to again run it to go into
That we need to do it, sir.
no.
That effective width.
Maybe it is not showing. Maybe it is applied. I don't know why they are taking me the strat thing. That thing, different thing. So now another thing, if you remember longitudinal reinforcement we have provided. Now it is asking design position, design for output, the same thing. And shear connector, transverse stiffeners, there. Transfer stiffener and about, ladder rod and buckling, plate guard only. Fatigue details, serviceability, load combination type. Now it is not coming here anything. Why it is not coming here? If I go, yes, because I have not mentioned it. Again, first let me run it. Okay.
We have to give that, no, sir. Rare, frequent, that serviceability combination takes. Sir.
Hello. Hello. Everyone seeing my screen now? Hello.
हाँ यस सर।
हाँ,
यस सर दिख रहा है और खाने का आवाज भी आ रहा है।
हैं? खाने का मेरा नहीं है, वो कोई और खाना है।
जो भी खा रहा है प्लीज वो म्यूट कर लो।
अकेले अकेले खा रहा है।
अकेले के खा रहे हैं, आवाज आ रही भयंकर वाली।
So here in composite, first now we need to see which girder is governing, and also in the result load combination. The important thing is you can go into the composite design, and here our loads this from this point. I need to change this. No, no, okay. Steel girder. Now I will go in steel design. What it will say? SRS angular. Why it is not showing? This is not SRS or angular.
No, in this column, sir, active strength serviceability. That one.
Okay.
You are checking some other column.
I am checking in the add one. Right. So this will be changed into my serviceability. So let me try if I can able to copy this.
Which
Not
one,
able
sir?
to.
Which will be changed?
This from characteristic. Maybe I will look at the spreadsheet form. So it is changing from this.
From 76 like that, how you got to know, sir?
Not 76. You should remember from where the characteristic. If I have other loads added, so it will change automatically. It's up to you,
Okay.
not 76 or any other thing.
No, sir. Up to which combination strength, from where serviceability starts like that, that factors we have to know, see or something, no, sir?
I think I cannot able to continue something with the network is not working properly. So I might be able to drop that. So maybe you're getting my voice or not?
No, now again some issue was there. Again, now we are getting screen
No,
also not visible.
I'm not showing because it will going to happen some network issues there. So I cannot able to continue right now. Maybe tomorrow I will take 1 hour lecture also, so to finish this. So there are some issues with the Wi-Fi and my phone network is not working properly. So that is a thing out there. So I'm closing this. So we will continue tomorrow. Okay, because only 1 hour is also required. So up to that, maybe that effective bit, I will correct that. Okay.
Okay.
So because not able to continue like this, again it will go and again it will come. So for you also it was not good, and for me also representation.
सर जॉय सर एक
Yes.
सवाल पूछना था मेरे को अपना ऐसे
बोलो।
एक तो ये है कि अपना नेक्स्ट टॉपिक क्या रहेगा?
नेक्स्ट टॉपिक इसके बाद हम अभी वो करेंगे ना स्टील के ट्रस ब्रिजेस बताऊंगा, एक दो स्पेशल बता दूंगा क्या नाम है, जैसे अपना बोस्टिंग गर्डर होता है या नेटवर्क टाइड आर्ट ब्रिज होते हैं। अभी स्टील चलेगा
अच्छा।
एक दो, फिर उसके बाद देखेंगे। ठीक है।
अच्छा सर ये पूछा था ये सिविल ये मिडास जनरेशन आता है एक तो और मिडास सिविल दोनों में डिफरेंस क्या है अपने?
मिडास जनरेशन में तुम्हारे ये सब नहीं होगा यहाँ पे ऑप्शन, जो मिडास सिविल में मैं दिखाता हूँ ब्रिज मॉडल।
हेलो आवाज गई भाई साहब। हेलो हमारा नेटवर्क जियो के सर तो गए साहब।
Problem in SARS network.
यस विनेश जी यस विनेश जी आप क्या करते हैं विनेश जी?
मैं एक प्राइवेट कंसल्टेंट में काम कर रहा हूँ।
कहाँ पे? हैदराबाद?
नहीं बैंगलोर।
बैंगलोर ओके नाइस। ब्रिज डिजाइनिंग की पोस्ट पर?
हाँ
एट व्हाट पोस्ट? like with bridge designer, structural designer, or
Yeah.
highway
Bridge
designer.
designer. Bridge designer.
Okay. Nice.
Yourself?
Myself, Kuldeep Singh. I am a consultant also, working in sector of highway and structures.
Both.
I have my own. I have my own company.
Okay.
Yeah, I'm working in Rajasthan, basically.
Okay. Your company name?
Vignesh ji, what will our scope in the designing if we are new in the designing field?
What,
रवि
sir?
सर बहुत डिमांड है स्पेशल डिजाइनिंग में, बंदे नहीं है.
क्या हो गया?
यार मैं कह रहा हूँ कि जैसे अभी हम लोग फ्रेशर होंगे एज अ डिजाइनिंग फील्ड में, तो स्कोप क्या है? एक्चुअली मैं फील्ड पे 10 साल 8 साल से काम कर रहा हूँ, तो अगर डायरेक्टली ऐसा चेंज करना डिजाइनिंग में ठीक रहेगा कि क्या, कैसा थोड़ा
First basics you have to learn. Basics first सीखना चाहिए. Everything like
Ravi
concrete,
sir,
steel design,
Ravi
whichever you
sir,
want to go.
Ravi sir, not to worry. Once you enter to the industry, you will learn everything.
first enter to industries, na? That is the main question.
Yeah, you are
No,
already in
for
the industry.
entering
You
that
just have to
industry
change the
only.
codes.
Huh?
You are already in the industry. You just need to change your codes. Currently, you are working in the field. Then you will be transferred to the office. So better you must go for authority engineers. There will be you can learn also, or you can also get a respect for a
I-
seniority and
Now
experience
you
field
know
engineer.
know to read the drawings, how the drawings are produced means that is what is design. Now for that design only, first you have to read code books, then basics, then software, then in Excel how they are doing, like that one by one, everything.
No, on the site work, from the last 8 year, I am on site only. But
That is what
this is a
there
design.
you will be given on drawing, you will execute that, na?
Yes.
That drawing you know to read, so you know understand what is the structure, what is what, everything. Only thing is how that sizes are fixed, how the drawing come, that you want to know. That is what is design. For that
Correct.
only this all these things, software, then code books, then this our basic fundamentals. Then our design means nothing but first is analysis part, then design part. For analysis only this software we are using. This is a tool.
कागजी कार्यवाही है साहब, कागजी कार्यवाही डिजाइनिंग. बाकी तो आपको ही पता है फील्ड में क्या होता है. 19 का 20 तो होता ही होता है.
हाँ, वो तो होता है. हम लोग तो
19 का
अपने हिसाब
18
से वो
उन ठेकेदार 19 का 18 करता है, और जो क्लाइंट इंजीनियर होता है, अथॉरिटी इंजीनियर होता है, 19 का 20 करता है. बस ये होता है. प्रोजेक्ट चलना चाहिए, होना चाहिए, कंप्लीट होना चाहिए. ये मैटर करता है फील्ड में.
करेक्ट. बट फर्स्ट वी हैव टू डिजाइन ना.
आज डिजाइनर की इतनी फीस नहीं होती थी, तो एक दिन का खर्चा हो जाता है. कॉन्ट्रैक्टर का खाली पड़ी रहे मशीन तो.
करेक्ट.
वो सीधी सी बात है सर. देखो, क्या सर रवि सर, मैंने एनएच प्रोजेक्ट पे 2 साल काम किया है हाईवे पे, है ना. और एज ए पोजीशन ऑफ इंजीनियर. हाँ, तो मुझे इतना समझ में आया कि साइट वाला ऑफिस वाले को गाली दे रहा होता है, ऑफिस वाला साइट वाले को गाली दे रहा होता है.
नहीं, बस मैं विघ्नेश से बस यही जानना चाह रहा हूँ कि इंटर कैसे करना है डिजाइनिंग फील्ड में, इसके कोर्स कंप्लीट होने के बाद.
सर एंट्री तो देखो सर, कोई ना कोई लिंक से ही होगी आपकी इंडस्ट्री में वापस. जैसे आपको डिजाइन इंडस्ट्री में आनी है ना, तो वो आपके जैसे कि भाई आप जैसे आप कॉन्ट्रैक्टर साइड काम करते हैं या क्लाइंट साइड काम करते हैं, या अथॉरिटी इंजीनियर साइड. अभी
अथॉरिटी में.
तो अथॉरिटी इंजीनियर तो सही है सर. आपको जैसे आपको कोई ना कोई जो भी डिजाइनिंग फील्ड में जो है ना, उनमें से किसी लिंक बना के ही एंटर होना पड़ेगा. क्योंकि आप डायरेक्ट जाओगे ना, तो मोस्टली लोग इतना कोई इंटरेस्ट लेता नहीं है कि यहाँ पे फील्ड वाले आदमी को डिजाइनिंग में ले, अनटिल अनलेस यहाँ कोई रिलेशनशिप ना क्रिएट हो रही हो. तो वो आपको कोई ना कोई बंदा ढूंढना पड़े, कोई ना कोई बंदा ढूंढना पड़े आपके सराउंडिंग में, जो आपको ये चांस दे एंटर होने का.
यहाँ पे सब डिजाइन फील्ड में नहीं है ना, इस वजह से मैं पूछ रहा हूँ।
नहीं सर, अथॉरिटी इंजीनियर में तो ऐसा तो है नहीं भाई, आपका हेड ऑफिस होगा, वहाँ पर डिजाइन टीम होगी, तो कोई ना कोई तो जान पहचान आपके जो टीम लीडर है उनसे जान पहचान हो जाए, या फिर जो भी आपके टीम यहाँ पर जो प्रोजेक्ट मैनेजर है, प्रोजेक्ट इंचार्ज है, उनके थ्रू जान पहचान से एंटर हो, मतलब कोई ना कोई आपको इसी टाइप का लिंक बना के ही एंटर होना पड़ेगा। फैक्ट बात
करेक्ट
तो ये है। और बाकी
करेक्ट।
आप ऑनलाइन वेबसाइट से उन पर चले तो जाएंगे, लेकिन वहाँ दिक्कत हुई आएगी कि डिजाइनर की पोस्ट ऐसी होती है और आपकी कंडीशन ऐसी है कि फॉर एग्जांपल मैं एक हायरिंग कर रहा हूँ, है ना, मुझे स्ट्रक्चर डिजाइनर चाहिए, आपने एक कोर्स कर लिया, आपका सर्टिफिकेट है, लेकिन आपके पास डिजाइनिंग एक्सपीरियंस नहीं है ना, अब मैं
करेक्ट
आपको हायर करूंगा तो आप जो सैलरी एक्सपेक्टेशन कर रहे हो 10 साल की फील्ड वर्क के बाद में, उस पे मुझे एक्सपीरियंस डिजाइनर मिल जाएगा। ठीक है ना,
करेक्ट।
तो मैं आपके लिए रेयरली कोर्स तभी जाऊंगा जब मेरे पास ड्यूल काम हो कि हाँ भाई ठीक है, इनको डिजाइन भी आती है, इनको फील्ड भी संभालना आता है, तो उनको फील्ड पे लगा दो, जहाँ पर डिजाइन चेक कर लेंगे हमारी, कि फील्ड में कोई डिजाइन दिक्कत आएगी तो हैंडल कर लेंगे अपने लेवल पे, या फिर हेड ऑफिस में कन्वे कर देंगे। तो उसमें भी आप
करेक्ट।
प्रैक्टिकली वो चीज सीख नहीं पाओगे, है ना, आपको डिजाइनिंग इंडस्ट्री
हाँ।
मतलब डिजाइन में ही प्रॉपर उतरना है, तो उसके लिए फिर आपको थोड़ा एक तो बैकलॉग, सैलरी वाइज तो बैकलॉग आना पड़ेगा फर्स्ट ऑफ ऑल।
हम्म,
और मतलब सीखने के लिए आप प्रॉपर डिजाइन करोगे तभी आप सीख पाओगे एक्चुअली कि हाँ डिजाइन कर रहे हो आप, मतलब कि डिजाइनिंग में क्या चीज है क्या चीज नहीं है, ये है। और वो तभी हो सकता है जब डिजाइन पे सीखो, और वो तभी होगा जब आपको कोई खासम खास आपको अंदर डिजाइनिंग प्रोजेक्ट पे डिजाइनिंग के ऊपर ले ले आपको।
हम्म,
अदरवाइज आप वैसे अगर आप ओपन मार्केट में जाएंगे तो आपको फिर वो बोलेंगे कि साहब आप तो डिजाइनिंग में तो फ्रेशर हो, आपको ये एक्सपीरियंस नहीं है, आप या तो ये सैलरी पे काम कर लो, तो वो सैलरी आपके लिए फिजिबल नहीं होगी, सीधी सी बात है।
सीधी बात वही है।
ये है, तो आपको एंटर तो आप अथॉरिटी इंजीनियर तो बढ़िया है, क्या अथॉरिटी इंजीनियर में तो भी आप एक बार को वहां से थोड़ा सा रूट बना के आप एंटर हो सकते हो, एकदम से तो आप एंटर नहीं हो पाओगे, आपको रूट ही बनाना पड़ेगा धीरे धीरे।
देखते हैं क्या
ये
हो
है।
सकता है।
No, if you enter also, they will take like fresher only first initially. So that's why you have to
हाँ
learn
हाँ,
more things. Then only you are
उसमें भी
possible.
एज एज अपने आप में एक चैलेंज होती है, एज के साथ में ये आदमी रिजिड हो जाता है, तो वो नई चीजों के लिए इतना ओपन नहीं होता कि सीख जाए, कैप्चर कर ले, ग्रेस्प कर ले, स्पीड वो हो रही होती है, और उनको डांट नहीं सकते बड़े लोगों को। फॉर एग्जाम्पल मैं आपको हायर करूँ तो आपको डांटने में कतराऊंगा क्योंकि आप मेरे से उम्र में बड़े हो या बराबर के हो।
करेक्ट करेक्ट।
मैं जो फ्रेशर होता है जो गलती भी कर 10 बार डांट भी दो, गाली गलिया भी दो उसको, तो बुरा नहीं लगता क्योंकि जूनियर है। तो एज फैक्टर बहुत मैटर करता है इंडस्ट्री के अंदर भी, प्रोफेशनल तो फैक्टर करता ही करता है।
देखिए अभी इंटर करने का कोशिश तो कर रहे हैं जितना हो सके।
जरूर सर, जरूर सर, करिए करिए। हम तो आपको आपको गुड विशेष दे सकते हैं, हमारे को कोई हमसे कुछ होगा तो आपको ऑप्शन बता देंगे।
बिल्कुल।
Your name, sir? KJ
एक
means
एक
what name?
माई सेल्फ कुलदीप जाटव।
Huh?
कुलदीप जाटव।
Kuldeep Jadhav.
जाटव जाटव।
Jatov.
एक्चुअली क्या है कि वो मेरी जो आईडी है ना, वो केजे नाम से बनी हुई है, तो उसने केजे ले लिया, मैंने डिफॉल्ट ले लिया, और कुछ
ठीक है,
नहीं।
ठीक है, ठीक है,
मुझे
ठीक है
लगता है
सर.
सर बिना कैंसिल करे जा चुके हैं।
हाँ।
हमें भी जा, मुझे लगता है सर वापस नहीं आने वाले, कल ही आएंगे अब तो, अपन लोग भी
हाँ।
चलते हैं।
ओके ओके।
ठीक है,
ओके
बाय
सर,
सर.
गुड नाइट। गुड नाइट सर, गुड नाइट मैम।
गुड नाइट गुड नाइट।
गुड नाइट.
गुड नाइट।